How's it going, guys? Today in this video, we're going to be going over the Chapter 7 part of the final exam review that you should have if you're taking the final. So let's go ahead and just get into it. So on number 1, we need to decide if the expressions can be written as A, a sum of cubes, B, a difference of cubes, C, a difference of squares, or D, there's no factoring pattern that exists. And we're saying sum can be used more than once. So n cubed plus 8, that's a sum of cubes. That's because n cubed, that can be rewritten as n cubed plus 2 cubed. So we literally have 2 cubes being added together. We're finding the sum of 2 actual cubes. Next, we have 27 minus t to the 9th power. That's B, a difference of cubes. And that's because we can rewrite this as 3 to the 3rd minus t third to the 3rd. So t to the 3rd, all to the 3rd, that's still a cube. A cube of t to the 3rd. It's a little confusing to think of it, but it is still a cube. So that's why it's a difference of cubes. You're taking the actual difference between two different cubes. Y to the 7 minus 9. There's no factoring pattern that exists there. 36 plus 4c squared. Same thing. No factoring pattern exists. Because there's not a sum of squares, it's only a difference of squares. So sum of squares isn't an actual thing, so that's no factoring pattern exists. 9 minus x to the 4th, that's C, a difference of squares. We can rewrite that as 3 squared minus x squared all squared. And you have an actual difference of 2 squares. 11p to the 3rd plus 64, that's D as well. There's no factoring pattern that actually exists there. All right, number 2, we need to simplify. So we have 2 polynomials, or really 2 binomials that we need to combine. So what I'm going to do is I'm going to distribute out that negative, so I can just add like terms. So I have 12a squared minus 8a minus 3a squared plus 3a. So just distribute out that negative, and now we can just add like terms. 12a squared minus 3a squared. That's a 9a squared. We can cancel those out. Negative 8a plus 3a. We can combine those to give us negative 5a. And that's our answer. Next, we're going to go on to number 6. 3, 4, and 5 are very similar. Just do it the same way. And we do have the completed key already on Canvas. You can double check your work and see what we're doing on the completed key. But on to number 6, we're told Carla has a rectangular swimming pool in her backyard that has a length of 20 feet and a width of 10 feet. So let's go ahead and draw that out. Carla has a swimming pool. Let's make it blue for the water. That's our swimming pool. And we're told that it's 20 feet wide, 20 feet long and 10 feet wide. So 20 feet long, 10 feet wide. Next, we're told she wants to install a concrete walkway of width C around the pool. So now she wants to make a concrete wall or a concrete walkway. That's going to be C width around the whole entire pool. So everything here is all of C width between the pool and the edge of the concrete walkway. Next, surrounding the walkway, she wants to have a wooden deck that extends W feet on all sides. So on top of the concrete wall, she also wants a wooden deck. All right, and after that, that's going to extend W feet on all sides. So that means all of this right here is going to be W. All right. And now we need to find an expression for the perimeter of the wooden deck. So it says the hint to draw a picture. We kind of do the picture as we're going along. So let's go ahead and try to figure out what our perimeter is going to be, or what the expression of the perimeter is going to be. So remember, the perimeter is when you add up all the sides of whatever you take the perimeter of. So we need the perimeter of this big red square. So that's going to be everything from here all the way to here. Everything that's into here. So we see that from the edge of this red square, we have a W. So all the way down, this part right here is a W. Make it a little nicer. That's all a W. Next, from that blue line up to here, that's all C. And then from that line right here all the way up to here, we're told the width of the pool, or sorry, the length of the pool is 20 feet. So all of this right here is 20. And then from the edge of that pool to the edge of this concrete, that's C. And then from the edge of that blue line right here to the end of the wooden walkway, or the red square, is another W. So if we were to add all this up, we have 2 W's, 2 C's, and a 20. So it's 2W plus 2C plus 20. That's the perimeter of this whole part right here in the bottom of the square. And that's going to go for the perimeter on the top of that square as well. It's a square. It doesn't look like a square, but it's supposed to be a square. So the length of the bottom part of it will be the same as the top. So if we're doing it twice, we know half of the perimeter, not half the perimeter, but part of the perimeter is going to be this 2W plus 2C plus 20, all happening 2 times, right, for the top one right here and for the bottom one right here. Next, we're going to figure out the length of the other part of the pool. Let's move this down here. And that's going to be all of this right here. All right. So from the beginning of the green line up to that wooden deck, that's a length of W. And then from the wooden deck up to this pool right here, that's a length of C. From the concrete wall or concrete walkway to the pool is C feet. And then from the pool to the other side of that pool, that's all 10 feet. Right, we're told the width of the pool is 10 feet. That's where we're getting a 10 for that. And then from that dashed green line to this right here, that part right there, that's all C. The edge of the pool to the edge of the concrete. And then last, we have from the edge of that concrete to the end of the other side of the wooden deck, that's W. All right, so all this right here, if we added it all up, we have 2 W's, 2 C's, and a 10. So 2W plus 2C plus 10. And again, there's 2 sides of it, so that's going to happen twice. So we can multiply it all by 2. So kind of broke up the 2 parts, but this equation right there in green and this one down here in blue, we add them together. That's going to be our expression for our perimeter of the whole wooden deck. So in green, it was 2W plus 2C plus 10, all multiplied by 2, because it happens twice on both sides of the wooden deck, plus everything in blue right here. I'm actually just going to move it over. Add all that up. And when we do, or before we add it all up, actually, let's distribute out that 2 and add all like terms together. So we have 4W plus 4C plus 20. And we're going to distribute this 2 out as well to give us another 4W, another 4C, and a 40. All right, so we're going to add like terms up. And we get 8W plus 8C plus 60. And that's going to be our expression for the perimeter of the red or the wooden deck, or this big box in red. All right, let's keep on going. We're going to number 7 now. A rectangular garden has a length of 2x minus 7 feet and a width of x minus 4 feet. We need to find the garden's area. So remember, the area of the rectangle is length times width, and they gave us what our length is, and they gave us what our width is. So we just need to multiply them together to figure out our area. Remember, area is length times width. So our area for this problem will be 2x minus 7 times x minus 4. length times width. So now we're just going to FOIL this out. So distribute that 2x. So we get 2x squared minus, I don't know what, that 4 looks like a W, but it's x minus 4. There we go. So distribute that 2x squared minus 8x minus 7x plus 28. Just add like terms. Our area is 2x squared minus, I'm messing up completely on this problem. It's supposed to be minus 7x right there. Negative 7 times x is negative 7x. And then it's minus, or rather plus 28. All right, there we go. So add like terms, 2x squared minus 15x plus 28. There we go. That's the right answer. That's how you do it. Multiply length times width. Make sure you actually FOIL it correctly, and you'll get your area. We can't go any further from here, so that's what we get. Number 9, a triangular garden has side length of 5 plus 4x feet and 5 plus 6x feet and 7x. We need to find the garden perimeter in terms of x. So we're told it's a triangular garden, and they give us 3 different lengths. A triangle has 3 sides, and perimeter, you're just adding up all the sides. So we're just going to add up all 3 of these terms. 5 plus 4x plus 5 plus 6x plus 7x. That's going to be our perimeter. So just add like terms. And when you do, we have 5 and 5. So these add up to give you 10. Then 4x plus 6x is 10x. Plus another 7x is a 17x. So that's our answer. Let's just rewrite this with the x in the front. Doesn't matter a whole ton, but there we go. That's our answer. Perimeter will be 17x plus 10. Let's keep on going. Now we're going to go on to number 10. We're going to find each product. So 3a minus 2b, all the cubed. So if we're cubing that, that means it's the same thing as 3a minus 2b times 3a minus 2b times 3a minus 2b. And since these are all binomials, we have to FOIL it out. We can't just distribute out that cube like we talked about a little bit in module 12. But these are binomials, so we cannot just do that. You have to FOIL it all out. So when we do 3a minus 2b times 3a minus 2b, we're going to distribute out the 3a. We get 9a squared minus 6ab minus 6ab plus 4b squared. All right, all of that times 3a minus 2b. Let's go ahead and add like terms in this big first polynomial. We get 9a squared minus 12ab plus 4b squared, all times 3a minus 2b. And now we need to FOIL this out one more time. So 9a squared, we distribute it out to 3a and negative 2b. When you do, you get 27a cubed minus 18a squared b. We're going to do the same thing with negative 12ab. We're going to distribute that out to 3a and negative 2b. So we get negative 36a squared b and plus 24ab squared. And then finally, the same thing with 4b squared. Distribute that out to 3a minus 2b. We get 12ab squared minus 8b cubed. So we're just going to add like terms now. So 27a cubed, there's nothing like it. We're just going to bring it down. 27a cubed. Negative 18a squared b. We can combine that with negative 36a squared b. And when you do, you get negative 54a squared b. And now we have 24ab squared and 12ab squared. They have the same variables at the end, so we can combine them to get 36 AB squared. And finally, that negative 8B cubed, there's nothing else like it. So we just bring it down. And that's going to be our final answer, 27A cubed minus 54A squared B plus 36AB squared minus 8B cubed. And numbers 11 and 12 are very similar to that. This is probably the harder one of the three. Just to go back the same way, write it all out, FOIL it all out, and combine like terms. All right, let's go on to number 15 and 16. On number 15, what we're told to do is we need to factor these all out completely. So we have x cubed plus 5x squared plus 3x plus 15. For this one, we're going to do this by factoring by grouping. So we're going to group up the first two, x cubed plus 5x squared. And we're also going to group up 3x and 15. We're going to take out the GCF out of each grouping, each pairing. The first one, the first pair, the GCF there is x squared. And we're left with x plus 5 inside. And the GCF of 3x plus 15 is 3. So we can pull out a 3, and we're left with x plus 5. And since what we're left with are both the same in each pair, that means factor by grouping works. If it wasn't the same, it wouldn't have worked. So that means we can factor out the x plus 5 from each of those pairs to give us x plus 5 times x squared plus 3. We really just bring out what we took out in its own little factor. All right, and we can't really factor out any more from here. So that's our answer. X plus 5 times x squared plus 3. Now for number 16, what we're going to do here is first thing we need to do is we need to factor out the GCF. Always look for if there's a GCF you can factor out first. In number 15, there wasn't a GCF you can factor out from everything, but on number 16, 3m to the 4th minus 48 has a GCF of 3. So we factor out a 3, and we're left with m to the 4th minus 16. And now we can see that m to the 4th minus 16 is a difference of squares. We can rewrite this as m squared all squared minus 16. There we go. And 16 is the same thing as 4 squared. So this ends up being m squared minus 4 times m squared plus 4. And then m squared minus 4, that's still a difference of squares. And we can rewrite that as m minus 2, m plus 2. So that goes down to both of these. And m squared plus 4 just goes down. There's no such thing as a sum of cubes. So we just bring it down. And that's going to be our final answer. All right. So let's keep on going. 14, 17, 18, and 19 from that little group of questions that ask you to factor. They're all very similar, but for 14, 17, 18, and 19, those are going to be from your factoring patterns. So go back to the notes. We did post all the completed notes online on Canvas. So you can go on there and double check all your work from there, or rather than double check your work, but get the old notes from on there, and you can get your old factoring patterns from there. You do need to know those for the final. So practice your factoring patterns with 14, 17, 18, and 19. 15 and 16 were just a little different, so I wanted to go over those. All right, let's keep on going. We're going to go on to number 21. So for number 21, we need to find the remainder when 2x cubed plus 3x squared plus 1 is divided by x minus 4. We can use either synthetic or long division. We're going to use both. So for 21, we do synthetic division. We're going to take the factor of x minus 4, or the 0 from that factor, and we're going to do synthetic division. So the 0 from x minus 4, or the 0 from the factor x minus 4 is just going to be 4. We set x minus 4 equal to 0, and we get that x equals 4. Set the factor equal to 0, and that gives you your actual 0 of that factor. So to do synthetic division, remember you put the 4 or the factor you're dividing by in the little corner right there, and you list out all of the coefficients. So in this case, it's 2, 3, 0, and 1. You cannot forget any of your placeholders, right? Because we have 2x cubed plus 3x squared plus 0x plus 1. We don't have an actual x with a coefficient, not coefficient, but a not a variable, but a power of 1. There we go. We don't have an x with a power of 1, so you still have to put the placeholder of 0 in your synthetic division. All right. So we put it in. That's where the 0 comes from. And remember, synthetic division, you drop down the first term first. So you drop down that 2. And then we multiply 4 with 2. That gives us 8. And then we add down. So 3 plus 8 is 11. And we do it again. 4 times 11 is 44. 0 plus 44 is just 44. And then 4 times 44 is 176. 176 plus 1 is 177. And the very last term is your remainder. So our remainder for this problem is 177. So the answer to number 21 would be 177. But if we wanted to write out the whole answer to this problem, not just the remainder, but the answer to the actual division, we would write this as 2x squared plus 11x plus 44. These right here are your coefficients. And then your remainder, you write it as 177 all over your divisor, x minus 4. So the answer to this question is 177. That's just the remainder. I wanted to go over how to write your actual quotient or answer to the actual division problem. You would write it like that. All right. So we did this with synthetic. Now let's do this with long division. So it's x minus 4 divided by 5x cubed minus 6x squared plus 0x plus 5. Please remember to write your placeholders. And with long division, it makes it 1,000 times easier. So please just make sure you put it down. It's going to make your life easier, reduces the amount of mistakes you do. It just makes it that much easier. Anyway, now we're going to do long division. We're going to see how many times x goes into 5x cubed. In this case, that's, I'm sorry, not 5x cubed, but I was looking at the wrong problem. So we're going to rewrite this as the actual problem, which was 2x cubed plus 3x squared plus 0x plus 1. There we go. Sorry about that. We rewrote it as the, I rewrote it as the right problem now. So now we're going to see how many times x goes into 2x cubed, or rather x times what gives you 2x cubed, and that's going to be 2x squared. X times 2x squared gives you 2x cubed. So we multiply those together, or rather multiply the 2x cubed with x minus 4 to give us 2x cubed minus 8x squared. And we're going to subtract the first polynomial with the second one. 2x cubed minus 2x cubed is 0. X cubed. 3x squared minus negative 8x squared gives you a positive 11x squared. And we can just drop both of these down. Plus 0x plus 1. Now we're going to do the same thing again. We're going to see how many times does x go into 11x squared. Since that 0x cubed just goes away. X goes into 11x squared 11x times. Or in other words, 11x times x gives you 11x squared. And we'll do the same thing. Multiply x minus 4 with 11x. And when you do, you get 11x squared minus 44x. We're going to subtract that polynomial with the one we just made, just like before. 11x squared minus 11x squared. That's 0x squared. That's what we wanted. 0x minus negative 44x is a positive 44x. And we can just bring down that 1. And now we're going to do the same thing. x goes into 44 how many times? It goes into it 44 times. Or in other words, 44 times x gives you 44x. So 44 times x, 44x, and 44 times negative 4 is a negative 176. Subtract the first polynomial with the second one, the 0x squared goes away. 44x minus 44x is 0x. And 1 minus negative 176 is a positive 177. All right, and now we can stop here since there's no number I can multiply with x in the 177. So I stop here, and that 177 is my remainder. So I just add it at the end. 177, that's my remainder, that's my answer. But to write it as an actual quotient, we'll put 2x squared plus 11x plus 44 plus 177 divided by x minus 4, or what you're dividing by. So that right there is the whole quotient, but the answer will be 177 since the question only asked for the remainder of that quotient. All right, let's keep on going. Or actually, that's the end of the Chapter 7 review. So that's it for Chapter 7. If you want to go over Chapter 8, there's going to be a video for Chapter 8 as well. And if you have any, if you want anything more in depth, remember we do post completed notes online, so you can go back and look at your old notes, even online. If you ended up losing your note packet, it's still all online. There's still old videos online, and the completed key is also online if you want to double check the rest of your work for that Chapter 7 part of the final exam review.